Hi guys, you welcome back to my channel. Today we want to take a look at the 2024 Neco examination. But one thing I want you guys to know is that what we have on the board is the alternative to practical. And mind you, the same thing I did for WAEC, I'll be doing the same thing for Neco. I'm using my small classroom. Pending the time I'll get my laboratory equipment. But that did not stop Chemistry Core for dropping a video which will help those students out there who are preparing for the external examination. So today we want to take a look at the alternative based on the teacher reports or based on what Neco provide for each school, compared to WAEC when we are having alternative A and alternative B. Neco one is different. Is that clear now? So to those teachers out there who are watching this video, pay max attention as well as those students out there. This is alternative to practical. So I will also be telling you guys a procedure based on the teachers' reports given to each of the schools. So guys, if we have this, A is a solution of hydrogen tetrahydrosulfate acid entail. Don't mind, the question you have on the board is likely correction to what you can easily or you can come across in the examination. Is that clear now? So entail 6.08 gram of the acid per dm cube. B is a solution of sodium trioxocarbonate. 4. Put A. Your A is this: the sulfuric acid. These are what? A. And sodium carbonate is what? Our B. This one will be in the conical flask. Is that clear now? So if you are putting this A into the burette where we have our stand, so the what? We have a meniscus where you are going to what? The water is going to stop there. Is that clear now? So when you put your A into this, are you with me? Then you pipette either 20 cm cube or 25 cm cube of this into the conical flask. And mind you, sulfuric acid is a strong acid, while this is a basic salt. So we are now saying we are titrating. This particular thing is on acid base what? Titration. Is that clear? So the moment you put your A into the burette, then you pipette this into the conical flask. Now we are going to, an indicator is needed, which is the what? Meteorange. The moment you put either 1 or 2 drops of the meteorange into this conical flask, it will change to what? Yellow. But when you titrate against the sulfuric acid, mind you, it is not a conc sulfuric acid, it is a dilute sulfuric acid. Is that clear now? So when you titrate against this, they get a particular meniscus where I'll be showing you the what? The table. The table of rating. So the moment you tabulate it, or sorry, the moment you titrate it, you titrate A against this, it will change to a pale pink. Is that clear now? It changes to what? A pale pink. The moment that it changes to a pale pink, then you stop. You take the reading. For the rough titration or the rough titer, the first titer, the second titer, if there is time for you to do the third titer, go ahead with it. You have your clue. Now let's go back to this now. As I've said earlier, that this sulfuric acid is a strong acid, while this is a basic salt. So this kind of titration is acid base titration. So now I have a question on the board that after we have done with the titration of everything, if you are paying attention to what I've said as a teacher or as a student, I've shown you guys the step by step, that is the procedure of how you can easily titrate. Is that clear now? So this is our strong acid, this is our what? Strong base. So if these two is reacting together, okay, listen now. When these two react together, there will be a bubbles coming up. It will liberate a CO2 gas, which is what you are having here. Is that clear now? As well as what? The sodium sulfate. Are you getting it? So guys, let's take a quick look at the table of reading, then move to the calculation. So guys, this is the table of the reading. So now don't forget, I told you guys that this is alternative to practical. So as a teacher out there who is watching this particular video, or as a student streaming this particular video, you need to listen to your teacher instruction. And to the tutors out there, when you carry out the practical, this is a likely question, and mind you, don't forget the procedure which I have stated earlier before. So now guys, if we have this and we are to tackle these three questions here, this, and this, now the first we are going to do now is that it said average volume of acid used equal to the what? The first titer plus the second titer. I'm only using the titer value, so divided by what? 2. But if your teacher is telling you out there, or as a tutor out there, you have to make use of 3 titer value. That will be the rough titer first, second, then here we'll be having what? The third titer value. So which is going to what? Divide everything by 3 instead of what? Using 2, then you'll be dividing what? 2. So with that, let's go. If you check out this now, the difference between this and this is 0.5. It is what? Concordant. So you can say we have 21.0 cm cube plus 20.this cm cube divided by 2. So let's check. 21.00, you can see, plus 20.50, we have 41.50 cm cube divided by 2. So we have 20.75 cm cube. So please take notes. Take note of that. So our average volume of acid use is this. So automatically our VA is 20.75 cm cube. Now guys, let's take a look at the question we have been asked to solve on the board. So permit me to rub off this so we can easily get what we are saying and how we can easily tackle this kind of question if at all we come across it in our examination, which is stipulated to hold next week. So for this, so this will be needed. So we have 6. So let's put someone here, 6.08 gram of acid per dm cube. So we can take this off. So the first one is the concentration of A in mole per dm cube. How do we solve a question like this? Mind you, I dropped a video earlier last week under stoichiometry. So I want you guys to go and watch that video. So for this, if you are to have any units or any answer in mole per dm cube, this is a formula which you are going to use. Molar concentration The unit for this is mole per dm cube equal mass concentration in gram per dm cube divided by molar mass, gram per mole. So from that question stated that A is a solution of tetraoxosulfate 6 acid entail, is that clear now, 6.08 gram of acid per dm cube. Is that clear now? So where is the calculator? We are to look for the concentration of A in mole per dm cube first. So guys, how do we tackle this kind of question? The concentration of A in mole per dm cube, first thing you need to know is that the mass concentration in gram per dm cube is this value here. We have that already, but this we don't know it. So you can say molar mass of A, molar mass of A. So the A here is what? The acid, which is what? Sulfuric acid, H2SO4. So I said earlier that if you watch the video I dropped last week under stoichiometry, you'll find it's very what? Easy to what? Get. So let's go class. 1 times 2 plus 32 plus 16 times 4. So we have 2 plus what? If we punch our calculator, 16 times 4 will give us 64. So now 2 plus 32 plus 64, we have to be what? 98 gram per mole. And mind you, I see that this, the value for this is 6.8 gram per dm of acid per, so molar concentration. The unit is mole per dm cube. Don't forget, that's what we are looking for. Of A equal to 6.08 divided by 98. The unit for this is what? Gram per what? Mole. This cancel what? This. So is that 6.08 divided by 98. So our answer is 0. What we have here, 62 mole per dm cube, as I say. So we have those justice to this. This is gone. Are you with me now? So guys, you can see 0.0262. So that's for the concentration of A in mole per dm cube. This is how you are going to tackle a question like this. You don't have to panic if you are given anything question. When it comes to this, you don't have to what? Panic. Is that clear now? So guys, let's take these parts. So please take note of what we have done, please, and don't mind our little classroom and our board. So for this, we are asked to look for what? This now. So by doing that, you can say CA VA equal CB VB equal NA over MB. So I have to clean this. I have it in, so I'll show you guys here. We have it here, so I have to clean this so we can have enough space to solve. So by doing this, so we have this now. So let's pick. So guys, our CA, the concentration of acid used, the molar concentration of acid. So as I always said, please learn how to write all the parameters out. So we have 0.062 mole per dm cube. Our VA is given already to be what? 20.75 cm cube. So CB, it is what we are looking for, our unknown. Then VB, the volume of the what? Bread used. So I'm going with 25 cm cube. Our NA, NB. So let's check now. What is the number of mole here? Class. We have 1. For the base also, we have what? 2. Are you with me now? So we have all the parameters out there now. So we can easily, so by doing that, let's substitute for this. Is that clear now? So with that, I can set CB, VB, NA equals CA, VA, NB. With that, you said VB, NA, VB, NA. This cancel this. So our CB is this. What's our CA? 0.062 multiplied by, don't forget you need more per dm cube. So let's put it, don't worry. So we have more per dm cube multiplied by VA is what? 20.75 cm cube multiplied by 1. Our VB is 25 cm cube multiplied by 1. Cm cube what? We cancel the what? Cm cube. So guys, we take note of all we have here now. So I have to wrap off the what? The board. If there is need for us to make use of the equation, then I have to write it again. So let's go. So for this, we have CB equal, so 0.062 multiplied by 0.75, we have 1.2865 mole per dm cube divided by 25. So CB equal to, 0.052 mole per dm cube. So this is how we can calculate when it comes to the question. And the last one states that, but before we go to the last question, which states that volume of CO2 released or liberated at STP. So guys, before we can proceed to this, there's one thing I want us to know about this question. And for us to solve this particular question, I will have to revisit the equation which I cleaned earlier. So but before then, when it's come to you solving equation under this, I will advise all the students out there, learn how to write your parameters. Then you know that this particular one is the unknown. Just the way I did, I make my CB the subject of formula. Then by doing that, you can easily substitute all your parameters into it. Then you calculate. Is that clear now? So let's go back to this. Volume of CO2 released or liberated at STP. First and foremost, what is the molar volume? Molar volume at STP is what? 22.4 dm cube. Is that clear? So let's take a look at our equation back. The sulfuric acid plus our sodium carbonate. Don't forget, we're going to liberate sodium sulfate, liberate water, as well as what? The bubbles, which is what? The carbon dioxide. Is that clear now? So guys, how do we calculate for this? It is very, very what? Simple. The volume of our the value for our CB, which is the concentration of the B is 0.052 mole per dm cube. But before we go there, look at this. We have one mole here. We also have what? 1 mole here. So 1 mole of sodium carbonate is equivalent to what? 1 mole of what? CO2. But just because we are looking for the volume of this, that means we don't have any business with this anymore. Rather, we have to focus on this. By doing that, you can say 1 mole of sodium carbonate equal to the value of the molar volume at STP is what? 22.4 dm cube. So what is the concentration of the base given? This. So that will give us 0.052 equal mole per dm cube. Don't forget the unit. Y. Let me make use of what? Y. Well, so when you cross multiply, you can say 1 mole of this equal 22.4 dm cube multiplied by 0.52 mole per dm cube. The dm cube will cancel what? The dm cube. So 22.4 times 0.052. So we have 1.1648, and the volume of CO2 release or liberated at STP is what, class? So for this now, I will advise you to multiply this by 1000. By doing that, because if you decide to leave your answer like this, mind you, what we are solving on the board is a likely correction, but then I will tell you to multiply by 1000 based on my experience and my vouch on this. So when you multiply by 1000, this will be having what? 1. So that 1165. So we are talking about volume, not mole. That is more reason why we have to multiply it by what? 1000. So guys, the volume of carbon dioxide liberated at STP is what? 1165 cm cube. Is that clear now? So guys, don't forget to subscribe to Chemistry Core channel here. If you find this video educative